Hey guys, here's a quick video on dividing radicals. So the first problem I give you is radical 1/4, and I ask you to do it on your calculator. If you do this on your calculator, you're basically taking the square root of 1 over the square root of 4, which is 1/2 or 0.5. Now how I got to that point, I did it in my head, and obviously if you do it in your calculator you should get the same answer, is by using this next idea. That the radical of a quotient meaning something that's divided, equals the quotient of the radicals. So you have something with index of n, a over b. You could say that as radical a over radical b. So like in this past problem, we could have said it's radical 1 over radical 4. Square root of 1 is 1, square root of 4 is 2. That's how you get to 1/2. So in that sense with numbers, it's very easy. The issues start with, we get to variables. So let's just try a couple numbered problems. The first one, radical 7 over 64. Let's split that up. Radical 7 over radical 64. Radical 7 is as simplified as it can be, so we're going to leave it alone. 64, square root is 8. So that's radical 7 over 8, because that's as simplified as we can take it. I'll leave you guys to do 2 and 3, but actually, you know what? I'll do number 2. So radical 40 over radical 8. Now, neither one of those are perfect squares, but to find the biggest perfect square that goes into each. The biggest perfect square that goes into 40 is 4, and you're left over with the radical 10. On the bottom, you have a radical 4 and a radical 2. Right? So let's see what we're left with. Square root of 4 is 2 radical 10 over 2 radical 2. Now, you look at that and you say, it looks pretty simple, but it's not as simplified as it can be. You can take out the 2's, right? Because 2 divided by 2 is 1. And you're left with radical 10 over 2, right? Because if it's split up now, we can put it back together. These are equivalent ideas. So if you have something like this over this, you can make it into one big radical. And radical 10 over 2 is really radical 5. So that was kind of a long way to do this problem. If you look at it straight on, you see 40 and 8, you see the radicals being divided. You can just divide what's inside of them, like when you're multiplying. So you could have right away said radical 5. So I'll show you both ways on some of these problems. This is the long way where you split it apart and get to an answer, or you can see that these two things are divisible and simplify it down that way. So again, I'll let you try number 3. All right, now we're going to deal with variables. Variables create a whole different problem here. Let's split this one apart on number 2. So it's radical 60 x to the 3rd over radical 81 y squared. Notice how in the last problem both methods work. So I'll talk to you about what time to use each one. On this one, we look for the biggest perfect square that goes into 60, and let's see, I want to say that's 4. Yep. Nothing other than 4 goes in, so you have 4 left over with a 15. 4 times 15, 60. Biggest perfect square goes in x cubed is x squared, left over with an x. On the bottom, 81 perfect square. Y to the second is a perfect square, so you can simplify that right away, because you only have perfect squares here. So you get 9y. Let's simplify the top. 2x radical 15x over 9y. And that's as simple as it gets, so that's our answer there. All right, so let's try number 3. 128 y to the 4th, z to the 7th, over 216 x to the 6th, y to the 3rd. Notice now we have a cube root, so it's going to make things a little more interesting. So the cube root of 128 y to the 4th, z to the 7th, over the cube root of 216 x to the 6th, y to the 3rd. So all I did was take this problem and split it up, top and bottom. On the top, the biggest perfect cube that goes into 128 is 64. That goes into, and that leaves us with a 2. That goes into y to the 4th is y to the 3rd. Leaves us with 1y. Z to the 7th is z to the 6th. Leaves us with 1 z left. So this is all stuff we've done before. Now if you look at the bottom, we have another one where it works out to be perfect on the bottom. Cube root of 216 is 6. Cube root of x to the 6th is x to the 2nd. And cube root of y to the 3rd is just y. So now we simplify the top down. And we get 4y z to the 2nd cube root 2y z all over 6x squared y. So you're probably thinking we're done here. But we're not. The problem with this is, like I said before, if all your numbers are simple as possible, and you have only one of each variable outside of your radicals, you're simple. But in this case, we have 2 y's, and 4 and 6 can be simplified. So let's do that first. 4 into 6 is 2 over 3. Y over y, if we use our quotient rule, those would cancel out. So those don't exist anymore. They've canceled to 1. So it's z to the 3rd on the top, and then x squared on the bottom because there's nothing to combine those with. And we leave the cube root that we had from before. Alright, so that's how to do these problems when you have something that's perfect square or perfect cube on the bottom. Now there's cases where it's not a perfect square or perfect cube. And that kind of goes back to what we did on this problem right here, where we simplified first as opposed to doing all this work. When you don't have a perfect square or perfect cube on the bottom, you want to simplify your numbers. So let's try by dividing these numbers first and doing the quotient rule with our variables. So we have 864 divided by 6, which is 144, which is nice because we know it's a perfect square. Quotient rule between the x's gives us x to the 3rd, right? 5 minus 2. Between the y's is y to the 7th, 10 minus 3. Now we can simplify this. So our perfect squares are 144, x squared, y to the 6th. And we are left over with a x and a y, right? Because these are not even numbers, and since it's square root, we want it to be divisible by 2. Simplify this, you get 12x, y to the 3rd, radical x, y. So I'm going to leave you to do this one in class, and that should be it. Actually, you know what, I'll do one more. So let's do number 3, and I'll have you do number 4 in class. Number 3, we'll divide first again. So 56 divided by 7 is 8. Remember, this goes under a radical. X to the 5th over x is x to the 4th. Y to the 5th over y is y to the 4th. So we'll take out perfect squares. That's 4 is the biggest perfect square going in 8. X to the 4th, y to the 4th, and we're left over with a radical 2. That simplifies to 2x squared, y squared, radical 2. I'll let you do the cube root one in class. That one should be a little more challenging, but since it divides, it should work out nicely. All right.